Hi, and welcome to Chapter 17. In Chapter 17, we're going to cover how to troubleshoot your network. So when something goes wrong, how can you make it better? Let's get started. As you can see from our roadmap, we're getting towards the end, just 2 more chapters before we get ready for the test. To start with, we're going to look at CompTia's troubleshooting methodology. This sounds kind of funny to call it CompTia's because it's simply how you would normally solve a problem, but it steps it down into multiple steps so that you can recognize what do you need to do and make sure that you follow all of the steps to get finished the problem. The first step with any troubleshooting is going to be to figure out what the problem is. A lot of times new people will come in and someone will say there's something wrong with my computer, and they'll say, oh well, the last time someone said that, this is what the problem was, and they immediately go off in that direction. You don't want to do that. You want to talk to the person and you want to figure out what the problem actually is. Could be a series of things, and I've seen troubleshooting where you go through 12 different steps before you finally ask the question, so is the monitor plugged in? You have to figure out what the problem is first. Don't try to come up with an answer or a solution until you actually know what the problem is. So first step, always identify the problem. Ask the users what's going on, ask them a series of questions so that you can figure out where the problem might be located. Is it a network problem? Is it a computer problem? Is it a user problem? And then go forward from there. After that, we obviously come up with a theory of the probable cause. What are the different things that could be the problem? Come up with a theory. Then test your theory. So figure out, if this is the problem, what can I do to figure out how to solve it? Test your theory. So if my theory is that you're not connected to a network, we're going to do things like we're going to ping, or we're going to check our network settings because we think the problem is with the network. So establish your theory, then test your theory to figure out if you're right. If you're wrong, go back and establish another theory. So this is a series of loops as opposed to just going straight down. If you test your theory and your cause is not right, go back and figure out a different cause. After you figure out what the cause is, go establish your plan of action. How are you going to fix it? Are you going to reset the router? Are you going to reset the computer? Are you going to change your IP settings? What's going to be your plan of action as to how to solve it? At this point, we actually do something where we implement the solution. Sometimes you can't do that. Sometimes you don't have the right to shut off the router in the middle of the day while everyone else is using it. So you may want to escalate it to a superior or someone who does have that power. So either implement the solution yourself or escalate it to a higher authority. Finally, 6 is to verify that everything still works. Really important to make sure after you fix something that you test it to make sure that it's fixed and that everything else in your universe still works. I've seen lots of times where you make a change and you think, oh cool, I fixed the change, but you actually broke something else. So verify full functionality. If there's any preventative measures, if there's anything you can do at step 6 that says, okay, and we're not going to do this again, whatever it is that happened, if there is some way to prevent it in the future, you implement them at this point. Number 7, along with number 1, one of the more important ones, document your findings. Document what you did. It sounds silly if you think that you're the only one making changes or you're the only one that people can go to, but documenting your findings is really, really important in any type of a business environment. You want to document what did you do, what did you find, and how did you fix it. So the help desk ticket that's sitting here over on the side kind of gives you that description. So who is the person? What was their description of the problem? What actions did you take? And when are you going to follow up, if you are at all? It's important to keep this stuff documented, especially if there's more than one person working on anything. Even if there is more than one person, odds are you're not going to remember every single thing you've ever done in your entire life. Documenting can tell you, hey, the last time someone called with this problem, this is how we solved it. It'll tell you whether did that solution work, did your preventative measures not work, or is this just how I need to fix it, go do it again. So this is the basic troubleshooting methodology. In both the quizzes for this course and part of your CompTia exam are going to be questions that follow this methodology. What is the first thing that you have to do? After you establish a theory, what is your next step? Questions like this. So understanding the steps, and again, they're kind of common sense, but it's always good to document them, write them down, look at them as a list to make sure you've checked them all off. This course isn't really a hardware course or a computer operation course, but we do want to make sure you understand the basics of how a computer operates. So there are 3 basic stages of computer operation. The first is when you push the power button. This is the post test or the power on self-test. During the post test, if you have a failure, it usually means that the hardware failed. During the post test, and we'll describe the different stages here in just a second, you're going to be doing hardware checks, you're going to be checking your boots, and you're going to be making sure that everything is working correctly from a hardware point of view. So if you fail on your post test, this means that one of your hardwares has failed. It might have been your hard drive, it might have been memory card, it might have been your motherboard, your CPU, something in there, your memory, that has failed during post test. Second is where we finish the post test, but we haven't logged on yet. So everything in between. So loading and initializing of the operating system. So after the post test, but before you successfully logged on. This is the blue screen of death stage. So I'm sure you guys have all seen it. It's pretty fun. It usually means something's wrong with your operating system or something's wrong with your drivers. So it may be that the driver for your mouse or the driver for your keyboard or the driver for your monitor or the driver for any of your different peripherals may have had a problem. It doesn't always mean that your operating system is dead and your whole thing is dead, but it may be harder to be able to find that solution. We're going to walk through a couple of troubleshooting for that. Finally, after you have logged on, so you've typed in your login, your password, hit enter, you logged on, and then it crashed. This usually means that your software, something in your software or your services has crashed and failed. So this could be something wrong with an individual piece of software, usually on your startup sections, assuming that it happened right after login. If it happens in the middle of the day after you've been successfully logged in, it could be just a specific application you just tried to open. In the system configuration, you can choose how do you want to start up. So the screen over here on the side has the general system configuration page, and this is going to show you basic normal startup, where all the device drivers and services are loaded, diagnostic, where we just do the basic, or selective. This is where you can go in and you can have it start up at a specific style so that you can test things and look for what's wrong. Of course, if your computer can't log on at all or can't turn on, that's a different conversation. At this point, we're going to break through the different startup processes a little bit more in detail. So our detailed computer startup process. The basic standard order for a Windows 7, 8, 10 server up to 2016 follows the list here. There's a couple of other descriptions in the book, so I recommend you look at them to see the older versions of Windows. But for basic, most of the ones we have now, this is how it works. We start with our post test, as I said in the previous slide. Press the power switch. Your BIOS or your EFI, your firmware, is going to start the boot process. It's going to check the hardware to make sure all the hardware is working, which is why if you fail in the post test, that's where you would want to look at your hardware. All of your configuration data is then loaded into the CMOS. Okay, that's your post test. After your post test, we fall into the initial startup. So we go find what is called the master boot record. Really important thing to remember, MBR, your master boot record. And what it does is it identifies where the operating system is. Your boot record is going to look up and go find your OS. The BIOS is going to load the MBR into RAM. So the MBR is just the file that tells you where the operating system is. It is not your operating system. It's your master boot record. And this is going to load it into RAM. At this point, we talk about the different partitions. There is the active partition, the system partition, and the boot partition. Each of these different partitions of your drive are going to hold different pieces of information. Your active, or sometimes the first partition, is your operating system files. So this is where all of your operating system and most of what you're looking at. This is your C drive. We can have a system partition, which is your core files, which may be segregated out from your active partition just to hold all of the core files. Those are your system files. So if you hear the word core files, think system partition. The final is the boot partition. When we say the boot partition, it holds all of your device drivers and your services and any of your utilities. These are all of the extra pieces of information that need to go with your OS, but it's in a segregated partition. So our active partition is where all the operating system stuff is, boot partition, all of your drivers, and then your core files for your system. They sit on your system partition. So your BIOS at this point at your initial setup has loaded the MBR into RAM. If you have a dual boot, which we will talk about in a second, your boot manager will pop up at this point. If you don't have a dual boot, it skips this stage. So a dual boot is where you have the option of booting either, say, a Windows machine or a Linux machine. So same computer, separated into partitions. You can choose which operating system do you want to run if you choose to have a dual boot system. A lot of people are moving away from dual boot systems because of virtual machines, but it is still an option. So the boot manager will load up here and say, which OS do you want? Then we go into the boot loader stage. The boot loader is going to load the kernel. Remember, we talked about kernels before, especially with the Linux machine, because Linux is essentially a kernel with a bunch of daemons attached. So it loads the kernel at the bootloader stage. Loads it into RAM, but it doesn't execute it yet. So it's loaded, it's sitting there, and it's waiting. We also load what we call the hardware abstraction layer, HAL, which always makes me think of movies. The HAL, hardware abstraction layer, is designed to prevent your third-party software from directly accessing the hardware. Hardware abstraction layer, meaning that you have to go through the HAL to get to the hardware. Keeps outside programs from being able to directly access your hardware. That's intentional. So your MBR is hanging out in your active partition. It loads the kernel. So the kernel is now hanging out in RAM, and the hardware abstraction layer is loaded. That's the end of the boot layer phase. Then we actually load the kernel. Remember, we actually execute the kernels in the kernel loading stage. So we loaded the kernel up into the RAM, and it's hanging out there, and then the kernel loading stage actually executes it and allows the operating system to start the system. So it'll process the registry, setting the last known good configuration, and loading the session manager. This section of the book has a whole lot of steps that I am skipping, not steps, a whole lot of information that I am skipping here. This is a very long chapter, as I'm sure you found out by now. So I'm just kind of giving you the overview details that I think you really need to know, but I do definitely recommend you go in and you read these sections just to understand what are the executable files, what are the ones that I need to call, how does that work. Finally, after the kernel is loaded, we can go on to the logon stage. The logon stage runs your Windows logon or whatever logon executable that you need that prompts the user for their information. The startup programs are then loaded and run. As you may know, when you go into your task manager in Windows, you can set your startup files. You can do the same thing in a MacBook as well. Set up which files do you want to start on startup. You can choose to say, I want to start Microsoft Teams. I want to start my OneDrive. I want to start my audio supports. Things like this can be in your startup files. So when you finish the login phase, you're going to use the WinLogon executable is going to prompt the user, get their information, and then run those startup programs. After it's logged on, the local service authority, or the LSA, is going to also load and run the services. So any of the services that need to run are also going to get done at the same time as startup programs. So this is the little bit more detail of how a computer starts. Assuming that you're using a Windows machine, Windows-based machine, here's a couple of troubleshooting tools that you can use. The first is called Safe Mode. Safe Mode intentionally does not load all of the extra startup stuff. It doesn't load everything. It just puts you in a mode where any of those startups don't happen in case those are where your problem is. You can choose to have safe mode without networking, so you aren't connected to the network. If you think there's a virus involved, you might want to do that just because it keeps it from going outside. System Restore is an important one because it will allow you to set up the computer to be able to restore in the off chance that something fails. In your System Restore, you may have something where you can make a copy of your operating system as it sits now and make it as a restore file or an emergency backup. Your last known good configuration. Okay, so you booted up your machine, everything ran fine, and then you changed a bunch of things. And then you went and restarted your machine again and it failed. What it can do is it can choose to revert back to the last known good configuration, something that worked last time. If you have made changes to your registry, if you have made changes to your drivers, if you've made changes to your hardware, in between those two, the last known good configuration is what it was before you made all those changes. And it can revert back to that so that whatever changes you made essentially get overridden. This also helps if you updated something and the update crashed your system. You can make an emergency repair disk. This again is being able to take your entire system as it is now, store it similar to a backup, but it's just the repair disk. It's just what do we need to do to make sure that everything gets back to normal. There is an entire recovery console where you can go in and you can look at the different options in your recovery console. The important thing with drivers, you can look at the driver page under configurations and look at the different driver options that you can play with. So you can go in there and you can roll back your drivers, you can update your drivers, you can remove your driver altogether if you think the driver is a problem. And finally, your system configuration page, which gives you the option of looking at the different system services, the different boot menus, the startup options, things like this, and the different tasks, and be able to figure out if there are different ways you can configure your system. It used to be that you would have to hit that F8 button as soon as possible and then have to go in that way. If your computer's running right now, you can use your system configuration page to be able to change how you want your startup to occur, and that may help you with troubleshooting. Okay, most people don't notice that they need a recovery system until after something has failed. Wrong time. You want to make sure that you make your system image while things are still working. So a system image is an exact image of your current system, sector by sector, stored to keep things separate. This would be a system recovery option, system image. And that image is going to be able to be reloaded on or restored if necessary. Backups. This sounds always funny. Make sure you back up often and make sure you store them in a separate location. I have talked to many people, I always laugh, don't laugh, people actually do this, who back up their C drive to their C drive. So they're going to back up all of my documents and all of my videos and all of my stuff, and I'm going to store it on my C drive. If your C drive fails, you'll lose your backup as well. So back up to a separate location, whether that's a different drive in your computer, whether it's an external drive, whether it's to the cloud, back up to a separate location. You want to have your Windows installation disk. In the off chance that your entire operating system gets corrupted, you want to be able to have your installation disk. You can also have a backup and restore. So Windows obviously offers a backup and restore options so that you can back up your drive and be able to restore it with restoring software. Some people don't think about the fact that you need to have the ability to restore it with software. It's not like you just plug the drive in and it just knows what to do. You do have to have the restore software in there as well. If you go to a help desk, if you go to a tech shop, they may have a repair shop disk image available. They usually do. But if you can have the original OEM, equipment manufacturer disk, that's useful. When you install the operating system, it always goes on the first partition, and then it stores that copy or that image, that system image, on the second partition to allow you to recover it. So there's usually a secondary recovery partition on your hard drive in most operating systems today. You should be able to go in there. It may be hidden. That's intentional to keep you from messing it up. But it should be in there where you can restore from that. If there isn't, you may want to make one. It means that your operating system didn't make one automatically. We're going to really quickly touch on dual boot systems. As I said, people are usually using virtual machines these days, so we don't use a lot of dual boot, but it may happen. If you have a device that is a dual boot, or if you have one that's your personal device that's a dual boot, you have a boot INI file or a boot configuration file. This is your BCD, boot configuration data. Everything is stored in there that is going to tell the users which two operating systems, or multiple, which operating systems do you want to use. So your BCD is your boot configuration data. There is a couple of different things that you can do with your boot files in the command prompt, and it's important for you to actually realize the difference between these. So in your boot configuration data, you have your boot INI file. That's going to tell you which boot options you have. You also have, we talked about before, a master boot record. Remember, a master boot record says which OS am I going to use? Where is the location of the OS that I'm going to use? These commands down here, these boot rec commands, are going to help you to either resolve a corrupted BCD, boot configuration data, or resolve a corrupted MBR. So if you went in and you modified it and you messed up your MBR or your boot record, you can fix those. The fix boot allows you to write a new boot sector to the specific part, to the system partition. You can scan your OS, or you can rebuild your BCD. So rebuilding your BCD is going to scan your operating system to find any possible boot directories that you could use and put those into your BCD to build your boot configuration file for you. So you can rebuild that. The scan OS was Windows 7 or Windows Vista for the same thing, being able to look for an operating system on your drive. So rebuild BCD is the one you're going to want to use with your Windows 11 or Windows 10. And then again, in your system configuration, remember we have that boot that boot tab that gives you some boot options. We want to make sure that our server stays up to date and has solid integrity, that things work with it. If you're lucky, your server just works and it doesn't have any problems, but most of the time that takes a huge amount of skill. So when you are updating or installing or setting up your server, a couple of things to think of. First is a UPS, an uninterruptible power supply. We've talked about that before. You want to make sure that your server does not shut down ugly. You want it to shut down nicely when you ask it to, when you're doing checking on things and you're doing scheduled downtime. But you never want it falling apart because you had a flash of lightning, or you had a power surge, or something occurred. So you always want to have a UPS. RAID systems. We talked about RAID systems back in Chapter 9. A fault-tolerant RAID system is really useful in case one of your drives fails. Being able to have a secondary drive already in place means that your users don't know that anything failed. You know, but nobody else knows. Obviously, a backup system. We need to have a backup system because in the event that everything does fail, actual power outages or natural disasters, or someone spills coffee all over it, you need to have a backup system in place. Obviously, some version of antivirus and anti-malware. You want to have something on there protecting your server from outside attacks. And the last one, of course, is your service packs and your patches. If your server OS manufacturer issues patches and service packs, implement them as fast as you can. What it means is they usually have found a vulnerability in the software and they're trying to fix it. You want to do this. If there's a bug, if there's something that crashes, you want those as soon as possible. So your service packs and patches, make sure you implement those. All right, so this screen has 12 different things that you can use to troubleshoot your network infrastructure. So your network is in place, everything's working fine, and someone calls you and says, this stopped working. You need to know about all 12 of these to know what options you have available to fix it, to go find the problem. The first and probably the more important one that you're going to be using is your network diagnostics. So your Windows Diagnostic Utility, Windows Network Diagnostic Utility, is going to scan the system to look for errors. It's going to look at the NICs, it's going to look at the WinNS, it's going to look at your DNS and your DHCP. It's going to look around and figure out if there's something specific with your network. Obviously, your network and sharing center is going to be important because you're going to be going into there on an individual computer to make sure that you can see what the network is connected to and is there any troubleshooting problems you can do with that person's network. The network diagnostic allows you to look for network issues across, whereas your network and sharing center is going to be more related to an individual machine. Cable tester. You want to be able to make sure that the cables are not broken. Network cable tester is a basic little piece of information that you can get that says, do my cables work? Your tone generator and tracer. This is the thing that allows you to find the cable in the walls or in the ceiling or in the floor. So you can have the technician figure out where is that failure that we had with our cable. So we can test our cable to find out where the lines are. Obviously, fiber optic cables. We have the OTDR that we use for fiber to be able to test it with that light source. Sends a light source through and is able to recognize it on the other side, make sure that it works. So your OTDR is a really important part of your fiber if you have fiber running through your office. Your NIC loopback test. So your loopback test is going to allow a ping to test the hardware's ability to send and receive data signals. So it uses ping to be able to send an echo, come back, and test to make sure that your network card is working. That's the loopback test. Go there and come back. Your multimeter, used to detect connectivity. Again, these go back to some things that we've talked about before. Making sure that you test the resistance and the current of the actual power, or we're getting power through there. Spectrum analyzer measures the magnitude of the input signals. This may happen if your input signals are too weak to be able to be read. So spectrum analyzer is useful there. Obviously, the lights. There's little LEDs on your devices for a reason. Whether they're flashing, whether they're steady, whether they're on or off is going to indicate the status of whatever the device is. So whether it's a router or a hub or a switch, keep an eye on the lights. Is it lit up? Does it have power? Let's start with some of the basics before we start looking for something worse. Your network analyzer is generally a piece of software or hardware that we use to test the network. So it's just network analyzer as opposed to a protocol analyzer like Wireshark, where we capture and monitor the actual data frames. And the last is a wireless network tester and analyzer. So network analyzer and a tester. So this is sometimes some third-party things like NetStumbler that is going to allow you to do in-depth analysis of your network to look at your signal-to-noise ratios. We're going to talk a little bit about signal-to-noise ratios in a couple of slides. But being able to look at your wireless network and recognize that signal-to-noise, we use something like NetStumbler for that. At this point, I'm going to go ahead and run through a couple of troubleshooting options that you have. If this happens, this may be the reason why. So, a couple of slides of this. First, they can't log into the network. More often than not, they're typing in the wrong password. They have their caps lock on, they have their number lock on, they don't have their number lock on, or they could be trying to log into the wrong server or domain. Depending on how the login is set up with your network, if they type in the domain wrong, it's not going to work. Obviously, they're not a user on the domain that they've spelled wrong. It's hard. This is where people skills really come in. It's hard to tell someone, I think you spelled it wrong, but you need to find a way to prove to them that they spelled it wrong. So make sure that they check, hey, is your caps lock on? No. Could you look? Oh, wait, look, my caps lock is on. Yeah, I know. Wrong passwords. You can always choose to reset the password if you had such authority to allow them to say, okay, well, something was wrong with your password. I don't know how. It got kind of corrupted. Let's go ahead and reset your password to, new password, and then you have to go ahead and fix it and change the password everywhere else, and it's a pain in the butt. But you can do it. If there's no connection, so if you've taken the RJ45 or your Cat5 cable and you've tried to plug it in, but it's plugged in wrong, it's inserted incorrectly, make sure that you check the cable. Is the cable clean? Is it designed well? Is it broken? Is there any problems with the cable? We call these a dead drop because they're dropping packets. They're trying to send data or they're trying to receive data, but it's never getting where it's supposed to go. So we call it a dead drop. This is if there's either a loose or no connection. The worst is always a loose connection because they get some data, but not all of it. So you don't even think to go look at the connection. But that's where that could come in. If they can't access the individual share, so they have a network share that they want to go access, this is where all their data is. Check their permissions, make sure that they have permission to be on that share, and then ping the share location. Actually go ping it and make sure that there's no problem with the connection to the share. Could be that they're the first person who realized that the share went down, and that's fine. You just need to be able to say, what are the different options when you can't access a share? Can't print to a printer. Go ping the printer. Make sure that the printer is available. Go check the permissions. Big thing with printers, make sure there's paper. If the printer is turned off, if the power flushed and the power turned off, or the connection got failed, or it has no paper, you may not be able to print to the network printer. There's also a thing with network printers where they have a specific amount of disk space to store jobs before they get printed. If that is full, meaning that more people have sent jobs recently and it can't process them all, that's another reason why you wouldn't be able to print to a printer. So if you had 5 people all send their 2,000 page manuscript to the printer all at the same time, you may not be able to print to the printer. If the printer is printing, but it's printing gibberish, this usually means either a driver or a mismatched printer where they said that it was a one specific type of printer, an HP LaserJet, when it was actually not. So it got the wrong driver, it was set up wrong, it was misidentified. It could also be either a cache or a spooler issue, depending on how the printer is designed. But if the printer is printing gibberish as opposed to printing nothing, you want to look more towards the drivers or the way that the printer was set up. You may just want to reset up the printer to get that all cleaned up. If somebody has a virus or a worm, this is fun. Obviously, your antivirus problem is a thing. It could be that your software or hardware is misconfigured. Something was set up wrong. And it could be one of those hoaxes that pops up and says, hey, your computer is corrupted. And the answer is shut off the computer, disconnect it from the network, and I'll come look at it. Run it in safe mode, make sure it's not connected to the network. It may have just been a hoax, and that's fine. It's better for you to find that out rather than to reinstall the operating system or something crazy. Couple more troubleshooting. If you can't get an IP4 address, so you've connected and you're not able to connect to the network, go check your DHCP, check to make sure that you have DHCP enabled, check to make sure you haven't exhausted your address pool. Remember, the address pool is one of those things where you may only have X amount of addresses available. This could mean that more people are logging on and you need to increase your address pool. Ping your server. Make sure that from your server to the computer and the computer to the server, you can ping each other so that you can get to your DHCP. So those are important if you can't get your IP address. If you can't get to your application server, again, ping the server. Make sure you can get to it. Make sure that the path to the server is available. Make sure you have permissions to access the application server. And also make sure that that server isn't overloaded. If you have, again, lots of people hitting the server at the same time and you weren't designed for that, your demand could overload the server. It feels like a DOS attack where the server just gets hit with so much that you can't get in. So these are options if you can't get into your server. If you can't access your voice over IP server, check your VLAN switch. Make sure that it is configured for voice over IP. Make sure that it has not failed on you. And that's where a lot of the voice over, assuming you can get to the other servers, you can get out, but you just can't get to the voice over IP server, check your VLAN and see if that's the problem. Most of your devices are going to run in either half duplex or full duplex. Duplex mismatch is where I am trying to run half duplex or I'm trying to run full duplex, but they aren't the same. So one computer is going at half and the other is going at full, and there's a duplex setting on the devices that don't match. Make sure your duplex settings match on your devices. And the big can't access the internet. People are going to call you and say, I can't access the internet. You're right. Okay, let's go check. Do you have an IP address? Can you ping outside? Purge your DNS cache. ipconfig with a /DNS flush. Flush your cache. Reset your IP address. Release it and then renew it. So ipconfig, release, ipconfig, renew. And this will set you a new IP address from the DHCP. Check your protocols. Make sure you don't have a DOS or collisions or something bad going on. Make sure you haven't changed your firewall settings, that the user actually has permission to get through the firewall or vice versa. And then check your network adapter settings. Make sure that you are connected correctly and your adapter hasn't failed. Lots of different reasons for I can't access the internet. So you're going to have to check them all. If you are dealing specifically with a wireless issue, a couple of things that are wireless specific. Your ESSID, so your extended service set ID. Remember, we have our SSID, which is the name of the WAP, and then assume that we have multiple WAPs attached, so that we have an ESSID. So multiple WAPs going on through your entire office. If someone set up a new WAP that had the wrong SSID or passphrase, that can be a problem with ESSID mismatch. Obviously, we wrote in the wrong SSID, it's not going to be able to connect correctly. Wireless signals bounce. They bounce off of metal or glass or building materials. So if you have a signal bounce issue, it can actually make it where you can't get a good signal. The result, or the solution is move the device and or move the WAP around. If the WAP is solid, like it's already attached to the ceiling, move the device to a different location and see if it can get a better signal. So it may be related to a bounce issue. If you are using the wireless passphrase and encryption, make sure that the encryption is the same as what it's supposed to be. Remember, our wired equivalent, our WPA, and our WPA2. These are the different encryptions that you're going to be using. Make sure that they sync, that they're the same kind. Because if you have an encryption enabled and it's not supposed to be, or you are not enabled and it is supposed to be, you're going to have a problem there. And the last is that signal to noise ratio that we kind of danced around before. When you have the signal coming in wirelessly and you have background noise, if your background noise is so high that you can't see, you can't hear not hear physically, but your computer can't hear the actual signal, you can have a signal to noise ratio that's going to cause trouble. You can use a signal booster to increase that strength. And again, use that NetStumbler to figure out what that signal to noise ratio is. NetStumbler is going to be able to listen and it's going to go, okay, I'm getting X amount of background noise and my signal's coming in at this rate. If that ratio is too high, meaning that you have too much noise, you need to do something about that. So you can either use a signal booster to increase the strength, or you can see what you can do to remove the background noise. TCP/IP offers you a huge amount of utilities, usually in your C prompt, in just a command prompt, that you can do to check what's going on. There's only the 10 of them listed here, but you really ought to go play with these. Like, give yourself on this slide 5 minutes, 10 minutes to go into a C prompt and type all of these so that you can recognize, what do they tell me? What do they give me back? Starting with a ping. Again, all of these we have told you before. Starting with a ping, sends an echo, and using ICMP. So we send an echo to somebody and ask them, are you there? And they respond back. They're like, yep, I'm here. I'm all good. Cool. A trace RT traces the route from the workstation to the remote location and back. So we do a trace route. Path ping does both. So path ping is the trace route and the ping together. We do a ping, it's an echo, and we do a trace route. NetStat gives you statistics about your open TCP connections, whereas NBStat, NetStat is your TCP, NBStat is statistics about NetBIOS, again using TCP/IP. Your ARP tables, being able to look at your address resolution tables, you want to be able to look at those. Your IP config, this is where I go 90% of the time. Start with IP config and move your way down. So this looks at your configuration settings. Do you need to release them, renew them, flush them? Do you need to check them out in different locations? Check out your IP config settings. Your NS lookup. NS being that we have to go look up the actual DNS server information. So your DNS, your domain name server, it's the name server lookup. So we're looking at the DNS server. Route is kind of a generic, any routing tables that exist in my computer, as opposed to specifically a trace route. Route shows you your routing tables. And then net is kind of an overview in Windows. You can do net with a couple of different things. You can do net view or net stats to just look at the network. And again, all of these are in your book with much more details about them. Make sure when you're troubleshooting that you check the time. Time is kind of one of those silly things. Everybody gets the right time. If your time is wrong, some of the other things can be wrong. Certifications may be now expired because my time is wrong. The other is what we call our ACLs, or our access control lists. Your access control lists are parts that are going to say who is allowed to access what. Access control list. Makes sense. We're controlling access. But if your access control list is off, meaning that you have denied certain protocols or you have allowed certain protocols when you shouldn't be, if you have allowed certain IP addresses and not others, if your access control lists are off, that could also be a problem. Your SSL is going to have those certificates that make things get in and out. They're the secure socket link. Untrusted SSLs are going to cause problems. You can get your man-in-the-middle attacks because untrusted SSLs will allow the wrong person to come in. Again, with the change in TLS that came through in about August of 2020, a lot of sites suddenly popped up and said, we're no longer secure. And a lot of people said, I don't care, I'm going to go to the site anyway. Be careful of untrusted SSLs. It means that the site is not who they're claiming to be. Now, that could be fine. It could be that it's a subsidiary of that company and it just doesn't have the same name. But make sure you look at them. Just be aware of what's going on. For your assignments for Chapter 17, obviously you've got your review questions. Your study guide, you're going to go through 17.15. So there's a lot of them. This was a long chapter. For your lab activities, most of them are going to be go in and just look. Just look at how this troubleshooting tool works, how this one works, so that you can get familiar with the screens, so that you understand how those are going to work. Make sure that you go ahead and do as much as you can. Anything that feels uncomfortable, again, if it says to back up your computer and you've already backed it up, you don't have to do it again. If it says restore your computer, don't do that. You don't have to restore your computer. Your computer works fine. Because this is your own personal computer, I don't want you doing anything that makes you uncomfortable. So do as much of the labs as possible. Make sure that you do still, though, respond to the review questions, unless the review question says, did you do this? And you can say, no, I didn't, and move on with your life. So those are the labs. The study mates will be there, and don't forget to take the quiz. Thank you so much for watching this chapter on Chapter 17 on troubleshooting of your network. Come back next time for Chapter 18 and we'll finish it up. Have a great week.